break this up into multiple parts. So what we're going to do tonight is introduce the field and then talk a little bit about it. So here we go. I'm going to talk about the very beginnings of astrobiological thought. It might actually surprise you how long we've been thinking about this sort of thing. I'm going to talk about the statistical argument for life in the universe. And I'm going to connect that to the potential for life in our solar system. So we're only going to cover a few things tonight. We've only got 15 minutes. But I think this will set us up for further lectures in the future. Okay, so some of you probably know there was a mission today that involved firing something at the moon. Here we go. This is kind of funny. This is the way that I think about it. I'm going to play this because I think it's funny. So you've heard of the L-Cross mission. Basically, the idea was to launch something to hit the moon, and this would inject a cloud of debris, and then we would be able to see if there was water on the moon. Obviously, this is not that accurate. This was filmed in 1902. The launch crew are a little bit dressed differently than the normal NASA crew, obviously. They thought that a big cannon was probably a good idea. I'm not sure about that. But they get the next bit pretty much right, which is funny. Here we go. Even if you're using a cannon that big, it takes a while to actually get to the moon. There we go. Okay, so everyone's okay, which is great. Okay. There's a reason that I bring this up. There's actually two reasons. The first is that for some organisms, this isn't so silly. For us, obviously, it's ridiculous. You know, you can't have beards that big if you it's just crazy. The other thing is that old ideas can be very interesting, and sometimes old ideas can inform what we're doing in the modern world. So I'm going to connect this back to a story that I'm going to tell you. It's from a book. It's a short story by a guy called Chris Impey, a pretty famous scientist, from his book, The Living Universe, which is a great book. I suggest you all read it. So the scene is Asia Minor. The year is 584 BCE. We can imagine the scene as two Greek tribes are hacking away at each other with clubs and swords on a rocky plain near the shore. It's near noon, but the air chills and the sky darkens. Dazed and confused, the warriors drop their weapons and wander from the battlefield. It's a solar eclipse. History veers slightly in its course. 100 miles away, according to Herodotus, Thales has used knowledge of astronomy to predict this event. He knows that solar eclipses are part of the rhythm of the heavens and not omens from vengeful gods. It's a pivotal moment in history, the first recorded time that humans use sheer intellect to make sense of the cosmos. Now, why do I bring this up? Because there was a lot of stuff being figured out at that time. We're talking about the 6th century BCE, and Leucippus proposed that if you took pretty much anything and cut it in half, and then took those pieces and cut those in half, and cut the resulting pieces in half, you could carry on forever, going down further and further with smaller and smaller things. One of his students, Democritus, had a problem with this idea, and he thought, surely, at a certain point you get down to indivisible size, you get down to the barest constituents of nature. And so he proposed that this indivisible object was called an atom, and that these atoms made up everything in the world around us. Now, why am I telling you this? Why did I tell you about the beginning of science and the concept of atoms? Well, because Democritus went a little further, and he also theorized that the moon had mountains and valleys, and that the Milky Way was made up of innumerable stars. He, in a famous quote, well, I'm not sure if this is a direct quote, but I would rather discover a single cause than become king of the Persians, he said. This guy was a pretty serious scientist. So here we see that he was developing the very first scientific idea of the many worlds hypothesis. Maybe, he thought, if everything is made of the same stuff, and the things that we're seeing in the heavens are similar to the things that we see in our own backyard, maybe we could have many worlds that are all the same, perhaps the same as the Earth. So, where are we? obviously there were a lot of questions, and this is one of the really good things. This is one of the things that the Greek philosophers were really good at. They were really good at asking questions. They were really good at asking scientific questions. So, in the modern age, we have a lot of questions too. And we ask questions like, well, if there are innumerable worlds, if there are many Earths, well, where are the aliens? Why do they seem to like messing with our crops? Why do they like visiting the Midwest? And perhaps most importantly, we echo a question by Lucian of Samosta. Are we alone in the universe? Another guy put it really well when he said there are infinite worlds, both alike and unlike this world of ours. We must believe that in all the other worlds there are living creatures and plants and other things we see in this world. Completely untestable at the time, as it is now, but we're making inroads for the first time into actually being able to answer these questions. And I think that's really cool. So, obviously, if there's so much life, well, where is it? I'm going to answer the question by saying I love the fact that Josh is sitting in the background. This is excellent. I'm going to make some emotive arguments. I'm going to give you an optimistic view of just how possible I believe it is that there is life in the universe apart from the Earth. So, I'm going to say, most probably, I can't give you the statistics, but I'm going to give you some arguments that absolutely don't disprove that there could be life outside the Earth. That's my disclaimer. Alright, so one of the most important things, and I think this is actually an argument which, as far as I'm concerned, sums up the whole thing. It's an idea of the Copernican or mediocrity principle. Basically it says that we are not in a privileged position in the universe. You know, we've gone through a lot of different cosmologies, we're learning more and more about our place, but there is nothing special about the Earth or about our position in the Milky Way and our position in the universe or even ourselves. So if it can happen here, there is no reason that it can't happen anywhere else. And I could stop the talk there, because that's basically the point that I'm going to make. But I'm going to go a little further, and I'm going to start with a physical argument. So, it's all about location, right? If you're going to have life, you need to have somewhere to support that life. Now, this is the Ptolemaic universe. This is with the Earth in the center, with the Sun orbiting. It was a pretty good model for its time. It was popular for over 2,000 years. Of course, Copernicus mixed this up a little bit. He put the Sun in the center, the heliocentric model, pretty much the same as what we believe now, not what we believe, what we've observed. The interesting thing is that Copernicus actually still believed that the most distant circle was actually a fixed crystalline sphere of stars. So it wasn't quite right. So let's move through to a more modern perspective. Let's look at the universe made up of galaxies. As Laura said, those galaxies can make up clusters, but within those galaxies are many, many star systems, and hopefully many, many planets as well. I'm not sure what this is going to do. I can't actually remember what the next slide is. That's okay. Okay, so if we take one of these galaxies, well, we know that there's not just one galaxy, right? We know there's a bunch of galaxies. So we're going to add all these up. In fact, there's so many galaxies in the universe, you don't actually have to go very far before you have as many galaxies as I'm putting on the screen. There's actually 56. So what are we going to do with these galaxies? Well, let's do a calculation. This is sort of like the calculation that was in Contact, except you'll notice if you watch Contact in the movie that they actually got the math wrong, which is funny. I don't know how they missed that. So